Guys, you're welcome to this particular video. So I came across this blog and I find the blog very interesting, and I felt that we should have a discussion around it, read through the blog and get to understand exactly what is aggregated blockchain, right? So let's go through the blog together. By the way, my name is Obina, and I've been working in Web3 space for some time. And so let's see what this blog is all about. So this blog is by Polygon Technology, a leading blockchain company. So it said learn about aggregated framework and why it's going to make life in Web3 simpler for users, developers, and chains. So I want to give us some context around what aggregated blockchain means, so that as I'm reading along, possibly you understand better, right? So I've already gone through the blog, but I just wanted to share it. So the concept of aggregated blockchain is a concept where Polygon intends to aggregate different sovereign chains into a single bridge, right? Into a single protocol called the AggLayer. So currently, if you've been in Web3 or you are new or you've been using it for some time, you realize that every chain like Optimism, Polygon, ZK, EVM, Arbitrum, all are sovereign chains operating on their own universe, right? So there is no intercommunication between this chain. I cannot directly communicate with Polygon POS to Optimism and vice versa. So let's say, for instance, I have some poll in my wallet and I want to send this poll directly to Arbitrum, right? To send it directly to Arbitrum, and it becomes a poll native token on Arbitrum. I can't do that. So what happens is that I have my Arbitrum sent back to L1 and then go to the Polygon portal bridge and then bridge back my L1 token, maybe at ETH, back to poll. Vice versa, the same thing too. If I want to do for Arbitrum, I go to Arbitrum bridge my ETH to Arbitrum. If I go to Optimism, the same thing happens. So there is no unified layer whereby I can actually exchange messages between this sovereign chain. This is the problem that aggregated blockchains want to solve. A bit of a context there, right? If you've been using bridging, you testify to this. You will know about this. You know that this is a very hectic UI. The UI is really very difficult because I need to check out the different bridges to be able to move around tokens, right? But Polygon POS or Polygon technology understood this problem and decided to solve it using the aggregated blockchain. So let's continue, right? So the beginner's guide to aggregated blockchain. So as an approach to scaling blockchains, okay, the aggregated category is brand new, definitely. And that's why we're trying to know what it is. It takes the best of the previous methods and combine them. But what does an aggregated blockchain approach actually mean? Yes, that's what we want to know. What does it actually mean? So let's see the definition they have here. They say it is a horizontally scalable multi-chain ecosystem that enables access to shared liquidity and state across connected chains. So let me break it down for you. It is a collection of different sovereign chains on the same horizontal plane, right? We can call it a horizontal plane or so let's look at it as a table. Every chain comes to the table. All of them are on the same table. And therefore, if users on Polygon POS want to access OP from Optimism, because they are on the same plane, I can directly access ARB native token directly on Polygon POS. The same thing if we are on optimism, because we are on the same plane, the same ecosystem, I can directly from ARB Arbitra access Pol token without having to bridge, without having to do these complex activities of having to go to individual bridge and bridge from L1 to that particular network. So it makes life easier. So I think it's a supercharge. I can call it a supercharge to all these different sovereign chains, if you, in my own opinion, right? So there's no need for bridging, right? So you have everything on the same plane, on the same protocol, on the same horizontal plane. You just get connected, just be on that table, and everybody have access to shared liquidity, large pool of liquidity, natively, actually. So an aggregated approach attacks scaling architecture in a completely new way by aggregating sovereign chain. Sure. So aggregating sovereign chain, just like the name said, when you bring things together, you're aggregating them, right? So it brings all these different chains all in the same plane, all of them maintaining their sovereignty, right? They all maintain their sovereignty, but they are only on that plane in order to have access to enormous amount of liquidity without having these complex activities of bridging, right? So we will break down exactly what this means in this article. Okay, sure. So for users, an aggregated network can mean one-click transaction across chains. It will feel like the experience of being online, except in a web of protocol. Exactly. You know, when you are currently using different Web3 blockchains, right? They all look fragmented. It doesn't look as if you are actually browsing, because I can't move from a specific protocol or a specific blockchain to another seamlessly. Just like the way the internet is now, I can be on a particular web page. There's a hyperlink I can click directly, and I'm on a different page. I click and I'm on a different page, and all these pages are on different servers. I don't even know, right? But it doesn't feel the same way with blockchain, because everything seems fragmented. If I want to make use of Arbitron, I have to close my Polygon page, go to Arbitron, bridge, come back to, right? It doesn't seem, yeah, as if there's a communication, coordination between this fragmented or sovereign chain, just like the way you browse normally currently. And I can move from one page to another through hyperlink, and you don't even know that you are accessing servers on different continents, right? And it seems seamless. So that is what aggregated blockchain want to solve. For developers and chains, and aggregated blockchain. So what I just explained is how it will feel for ordinary users of the Web3 space. You won't even know that you are moving from one specific protocol to another, because of the ecosystem that is brought about by the aggregated blockchain, right? So for developers and chains, an aggregated network will mean tapping the user bases and shared liquidity of multiple blockchains, definitely. So developers can focus on market fit and not worry about competition for shared resources, bootstrapping liquidity or finding users. Exactly. So because every of these network are on the same plane, are all connected to the AggLayer, you don't need to worry about about share resources, right? Because you come with your user base and you supercharge these users. I feel like this particular I feel like this particular implementation, which is already live by the way, is not a white paper. This is not a white paper by the way. This is just something that is already live, and a lot of chains are already connected to the AggLayers. Specifically, I know of OKS, I know of Ista ZK EVM, right? They're already connected to the AggLayer and comes with their user, and they have access to this shared liquidity. So let's continue. So the chains enjoy unparalleled network effects and keep their sovereignty, definitely. So for you to be subscribed to AggLayer doesn't mean you are losing your sovereignty. You have your sovereignty. You are only connected because you want your user base to have access to share liquidity to make life easier for them. I think it's going to lead to mass adoption, where users have easily access the the POL token, the OP token, the ARB token. They have access to L1 token, which is in the escrow, right? It is just so easy. It will feel like the internet just as it is now if chains get on board, right? So all of this is just the start. The first component of AggLayer, a neutral technology with core contributions from. Okay, so they are telling us how the AggLayer is being built. So we have contributions from. So it's a community-driven project. Actually, it's not as if it is all driven by Polygon Lab. It's a neutral protocol that is not tied to a specific protocol per se, but is basically led by Polygon Labs. They are leading the way, and they are contributors like Suckins Lab, Toposware, and many others who are already live, right? So in April 2024, a top crypto exchange, OKS announced that they've deployed their layer 2 blockchain powered by Polygon CDK. By the way, we're going to talk about Polygon CDK. So they announced that they joined the AggLayer, which is the unified bridge, and they came along with about 50 million users, giving them access to unimaginable amount of liquidity and network effects. So Polygon CDK is basically a roll-up that powers the AggLayer, right? So if you want to deploy your own ZK powered blockchain today, the Polygon Labs have CDK that you can out of the box deploy your own blockchain on testnet and mainnet. You don't have to stress yourself about how to build your own protocol. You already have a tool, a blockchain tool called the Polygon CDK that you can easily deploy, and then all you need to do is to focus on what matters most to your users, fine-tuning your user base, and then you connect to the AggLayer and have access to unimaginable amount of liquidity. So let's go on. So they have a diagram here: monolith, modular, and aggregated. So let's discuss. Let me discuss a bit about this diagram that you're seeing here. So we have a monolithic, we have a modular, and we have aggregated here. So look at monolithic. If you are a developer, for instance, when you hear anything monolithic, it means it is not a microservice, right? So monolithic means that every of your services are just in one repository, in one big user, in one big folder, in one big repository, right? All your different services. So in terms of blockchain, we know we have different components of blockchain. We have the settlement layer, we have the execution layer, we have the consensus layer, we have the data availability layer, we have the application layer, networking layer. So in terms of blockchain, all these layers that I've just called out are all in one place, right? They are all in one place. That is why it's called monolithic, right? So the monolithic has a disadvantage, and the disadvantage is it is not scalable, right? It's not scalable. It's not easily adjustable. If there's a problem with one service, it affects the whole system. The whole system goes down. When there's a surge in transaction, it creates a bottleneck because everybody is struggling for the same resources. So that is the problem with monolithic. Example of that is Solana is a monolithic blockchain. Bitcoin too is a monolithic blockchain. We have Ethereum pre-sharding is monolithic blockchain. So because of this problem I just mentioned, came about the modular blockchain, right? So these are development in the last 15 years of blockchain. Have the monolithic blockchain where we have these different components of the blockchain all working in unison but in modular nature. They are all different, right? they are not all in the same protocol. So you have your settlement layer, you have your execution layer, you have your data availability layer. We even have data availability solutions, right? That's when we're talking about modular blockchain. Example of that is Avel. Of course, you know Avel was previously part of Polygon before they spin out. So Avel is a data availability solution. We have the settlement layer, we have the L1. So everything that is being executed is settled on L1. We have the execution layer, right? And we have all this layer, application layer, all modular in nature, communicating with each other. So it makes life easier, but the only thing is that it's difficult to develop actually. But after developing, it brings about massive scalability. Massive scalability. There is no specific point of failure per se. So you can easily add more services. You can easily change things. You can scale if there's a surge in transaction. There's no specific bottleneck. So all those disadvantages of monolithic was solved by modular, right? Which is what is currently in play in the Web3 space. So Polygon Labs are now leading the team talking about aggregated blockchain, where everything comes together, both the monolithic and modular comes together. So it takes the best of the both of them and brings it to aggregated blockchain. Therefore, solving massive amount of issues related to fragmentation, bringing about unified liquidity, right? Where everything seems seamless as if you are working in monolithic, right? Because in monolithic, everything is the same place. So now when you are in an aggregated layer, everything seems as if it's working in unison, but you don't actually know that you're talking with different protocols, different execution layer, and it seems seamless. So it's massive, it's very, very intelligent. So let's continue. So right now crypto is caught between a scaling debate with two sides. Yes. So on one side, the monolithic or integrated approach tackles the question of scale. I just described the monolithic blockchain, and so we understand what it means by defining it as a scaling access to liquidity and shared state. Basically, in a monolithic chain, all dApps and liquidity exist in a single environment. The data exists in the same environment. The execution is done in the same environment. The settlement is done in the same environment. Everything is done. dApps cannot communicate externally. They only communicate to each other in the same environment, right? So it's a problem. That is how monolithic work. In a monolithic chain, all dApps and liquidity exist in single environment. The integrated chains are the Solanas of this world. I think I mentioned that before. So Solana is an example of a monolithic blockchain. They run on nodes responsible for consensus, data availability, and execution, and serve to as a settlement layer. So everything is the same thing on the same node. Serve as settlement, serves as data availability layer, serves as execution layer, serves as consensus layer, all on the same node. So it is massive in terms of the kind of data it's storing. So this particular design could lead to state bloat, right? You're looking for space all the time. So by design, monolithic chain creates interoperability for dApps built atop the chain itself, definitely. So there's no way you can communicate outside itself, but not interoperability with other chains. The thesis of that adding more block space in aggregate doesn't matter that if that block space fragments liquidity and states. Right, so let's continue. Instead, the monolithic says blockchain should be integrated. Everything should be in one place. That's what it's saying. So the second argument on the other side, which is the modular approach, argues that any single chain will never be able to accommodate all the demands of the future Web3. I agree. Because requirements are changing. In an optimistic world of an internet-sized crypto environment, monolithic or monoliths wouldn't be able to handle the load. Definitely, it won't be able to handle the load. If there's a massive adoption, things will start breaking down. This is due in part to the very design that makes them successful now. Lodging around all that data in one place will lead to state bloat. I think I mentioned that before. And even with a ton of optimizations for parallel execution and local free market, there will always be competition for shares. There's no way there is no competition, because let's assume there is a surge in transaction. Everybody wants to settle their transaction. The settlement component becomes overloaded. Everybody wants to execute their transaction. The settlement service become overloaded, right? So it creates bottleneck here and there, and there is competition for different resources, for settlement, for execution, for available space. Everything is in competition. So once there's a massive adoption, it's not going to solve the issue of scalability, never. And that's what the modular design is arguing. So the modular approach splits up different blockchain components functionally. Take that. So modular leads to many chains serving as the execution layer of crypto, right? So you could have so many execution layer basically, and you decide the one you plug into. This approach gets a lot of things right? So different applications have heterogeneous requirement for security, latency, and user experience, right? So developers should build different execution environments that are fine-tuned to fit the needs of any given application. Because it is modular, so you have the freedom of building various types of execution layer and plug into it, right? Depending on the specific use case of the app you are building, right? So that is one of the benefits of modular design. And with a modular approach, state bloat and contentions are solved. Yeah, because everything is not done on the same node, right? Because they are all separate. You have your data availability component somewhere. You can even decide to use a data availability solution. You can have multiple data availability solution connected to your application, right? So you don't have to compete for space, right? So that's another thing. So the issue of state blocks is cleared out because it mustn't reside on the same node that you are running, just like the way monolithic is currently implemented, where everything is on the same node. So let's continue. So there's a Twitter post here. I will share the link to this particular blog that we are reading, so that you can decide to dig deeper and then go through the Twitter post if you want to. So, but modularity doesn't carry over a key value proposition of the integrated approach. Yeah. Modularity introduces fragmentation, right? So this post acknowledges there's a value proposition for monolithic design that we've been criticizing from the beginning, because everything seems integrated in the same place, and therefore you can easily communicate directly to whatever you want to communicate with. So it is predictable. You know that when you call your data availability component, you call your execution settlement, you know the response you will get, and everything is in the same node. So it is predictable and integrated. That is the value proposition, right? You don't have to guess if the execution layer is going to respond to you, or it's going to respond to you, right? You don't have to guess whether the data is going to be available. It's going to be available because it's in the same node. But of course, we talked about the disadvantage of that design, which is the monolithic design. So while this particular blog post is identifying the value proposition, it understands that the modular introduces fragmentation, right? Where you have different things fragmented in different places, right? So understanding this particular challenge with modular design. That's what led to this aggregated blockchain, bringing back everything on the same plane, right? And making it seem as if you are on the internet. You don't know you are moving from one server, one execution layer, one DA layer, one execution layer, one settlement layer to another. You don't even know because the AggLayer brings everything the same plane. So that's why from the beginning it says bringing the best of both worlds into the AggLayer. The best of monolithic, the best of modular, bringing them onto AggLayer, supercharging the Web3 space. So no matter how much liquidity, I'm here now, no matter how much liquidity and new block space are added to a multi-chain ecosystem, if states and liquidity are fragmented across chains, requiring cumbersome bridges or so I believe that my audience would know what bridge is all about, right? I think I explained that from the beginning. So because of this fragmentation using the modular design, liquidity and data are all fragmented. So let me show you an example of what I'm talking about here. I am here on Polygon portal. This is the bridge for Polygon. This is the bridge for Arbitron. This is the bridge for Optimism. I can't send my Pol token to Optimism. I can't send my Arbitron to Pol. I have to first of all bridge my Pol to Ethereum, and then I can then bridge from Ethereum to Arbitron. The same thing will happen if I want to bridge back to Arbitron from Optimism. I have to first bridge my OP tokens to L1 and then come back to Arbitron and bridge it back. So you can see that this is like a practical demonstration of what I'm telling you. So these are on different bridges. You kind of bridge around. So there is no communication between these protocols. Everything is just fragmented. It doesn't look like you are operating in the internet, whereby you just click things around and you are moving from one server to another without you even knowing. So that's what the AggLayer is talking about. It wants to solve this problem. So the aggregated paradigm is a synthesis of these two. So the aggregated blockchain is a combination of these two. It takes the best of the two, the best of monolithic and the best of modular. It brings them together, combining the best of the both worlds. A modular multi-chain approach where settlement happens on Ethereum, right? But one that fundamentally enables access to shared states and liquidity across the web of connected chains, giving the aggregated network an integrated feeling. It's modular and integrated. So the best of both worlds. The experience for users will be like a single chain, even as they go between different chains and execution environments, right? So when Optimism comes with their user base, Pol comes with their user base, Arbitron comes with their user base, Polygon POS come with their user base, Polygon zkVM come with their user base, OKS come with their user base, Asta zkVM come with their user base. Every of these user base have access to all these tokens from different execution environments without even knowing that they are talking to different execution layer. You don't know that you are moving from one execution layer to another, one settlement layer to another, because everything seems as if you are on the internet without having to kind of bridge around, right? To be honest, bridging is complex, especially if you don't know how to bridge, right? If you are new to Web3, you find it very confusing. To be quite frankly, for you to use the Web3 space, you should be a little bit of tech savvy to be able to do that. If not, you may lose your funding, right? So let's continue. So now we are talking about enter the AG layer for cryptographic safety. So let's see. So that's the subtitle. So the aggregation layer or AG layer for short is the first aggregated blockchain network, right? It is credibly neutral, so it is not protocol specific. It is neutral. It's a neutral service. It's led by the community. It's credibly neutral as it's a credibly neutral service that will accept proofs from connected chains, verify chain states are consistent, aggregate these proofs, and settle on L1. So every connected chain send them proof of whatever transaction they are executing. The AG layer verifies this proof, ensure that the chain states are consistent, aggregates this proof before settling on L1. So all the chains that are connected, OKS, AstaZK, KVM, Optimism, Arbitrum, all these chains that are connected send proofs of the transactions they have executed, and the AG layer, the unified bridge, collects them, aggregates them, and then settles them on. But before it does that, it cryptographically confirms that the states are consistent and the proofs are without issue. The proofs are not invalid before actually settling. So at a high level, this enables developers to build the best user experience and grow in a multi-chain environment. Developers retain sovereignty to build whatever, however, and still interoperate with other blockchain. Isn't it amazing? I think that is the major value proposition of the AG layer. Interoperability between sovereign chains and also having access to shared liquidity, massive amount of liquidity without having to bridge around, right? Without finding yourself in the wrong bridging URL where you lose your funds. All right. So while the AG layer provides unity, developers can select from modular toolkits like Polygon CDK, which enables team to create and customize a chain. So Polygon CDK is a chain. You can deploy your own chain, you can deploy your own blockchain, and you can customize it however you want. It's customizable, it is modular. You can decide the kind of token. You can create your own native token on using Polygon CDK, your own governance, your data availability, DA layer. You can customize it however you want. And once you deploy your own chain powered by zero knowledge technology, you can connect the AG layer coming along with your users and having access to immeasurable amount of liquidity. So when users do that and plug right away into the liquidity of the AG layer, Polygon CDK provides modularity. So it's a modular blockchain. It's modularly designed, while AG layer ensures that the integrated feelings of monolithic chain, right? So it's the best of the both worlds, modular and monolithic, coming to AG layer. Fundamentally, the AG layer will be a simple, cryptographically enforced service. So it is cryptographically secured. That's what it's saying, which allow different chains with different execution environments to safely interoperate at lower than Ethereum latency. So it's going to be very fast, more than Ethereum. That's what it means here. The AG layer cryptographically ensures settlement occurs on Ethereum if and only if there is no chain equivocation or the submission of invalid block. Definitely, there is no way it's going to settle on L1 or settle the proof of any connected chain if they send invalid block or invalid proof to the AG layer. So it is cryptographically secured, practically speaking. So let's break down this. The AG layer enables two things. Let's see what it's saying. What are the two things here? So asset fungibility. So what does it mean? Say it provides safety for chains to use unified bridge where L1 assets are locked. 2, low latency interaction. So it doesn't take time. It's very fast. It allows chains to coordinate or operate at a lower than Ethereum latency. In essence, this 2 point gives rise to shared liquidity. To this point, from Ethereum's point of view, AggLayer will look like a single rollup, right? It will look like a single rollup. This has a bunch of powerful implications. So let's say right now, users in any L2 ecosystem that want to transact across chains have two choices. So right now, users on any L2 ecosystem, be it Polygon POS, Polygon ZK EVM, be it Asta ZK EVM, be it OKS ZK EVM, be it Arbitrum, be it Optimism. If any user is in any of these ecosystem and they want to transact across chains from Pol to Asta ZK EVM, from Polygon ZK EVM to OKS, they can withdraw access to Ethereum first. So that's how it's currently now. You withdraw your asset to Ethereum and bridge to different L2. I showed you this bridge initially. So if I have any Pol token here and I want to communicate with Arbitrum, what happens first is that I have to bridge to L1. When I bridge my Pol token to L1, I will now come to the bridge of Arbitrum and then bridge back my L1 to Arbitrum. The same thing happens for Arbitrum. I bridge my Arbitrum to L1, then come back to Polygon bridge and bridge the token I bridge to L1 to Polygon protocol. So you can see everything is fragmented. There is no unity. So they can withdraw assets to Ethereum and bridge to different L2. This process is cumbersome. Yeah, it's very cumbersome. You can lose your funds if you're on different bridge, unfortunately. Or in the case of optimistic proof, requires 7-day delay. You can imagine. Or alternatively, the user can use third-party bridging services, which means synthetic token on the destination chain. Synthetic token is not a native token, by the way. So you don't have access to native token because of this fragmentation on the chain you want to work on. Because if you use that third-party bridge, it gives you a synthetic token. So the AggLayer offers a third solution, definitely. Because all connected chains would share a unified bridge, which is live. By the way, this thing I'm reading is not a theory or a white paper or a yellow paper anywhere. This is already live. I told you that we have a couple of CDK chains already connected, and I made mention of OKS as an example. Asta ZKVM is also an example. The AggLayer will enable asset fungibility. This means all L1 native assets for the entire AggLayer, right, across sovereign chains will be escrowed on the same bridge. So all L1 native token will be escrowed on the same bridge. Every user from all these sovereign chains will have access to that escrowed token. Asset fungibility. So if a user on Polygon ZK EVM wants to send Pol to a user on S layer in the future, they won't have to bridge around, like I mentioned, bridge from their Asta bridge to L1 and then bridge back to Pol. They won't have to do that because of AggLayer. So if a user in Polygon ZK EVM wants to send Pol to a user on S layer in the future, they will be able to send native Pol directly, not synthetic token. They will send native token, not having to bridge to L1 for bridging back. They will be able to send native Pol rather than a synthetic version of that that is wrapped or local to S layer, right? So native token can be moved through unified bridge and come out as native on the other chain thanks to the unified bridge. So if that's what it means. So if I'm sending Pol to Arbitrum, it will come to Arbitrum as Pol. It won't have to come as wrapped Pol, right? So native token can be moved around the unified bridge and come out as native token on the other chain thanks to the unified bridge. So we have a tweet here that you can go and check To the second point above, the AggLayer does not force chains to wait for a proof to be verified on Ethereum in order to enable chain transactions. So chains 2 does not even have to wait for proof to be verified because it is already cryptographically secured in that the AggLayer is going to process that and make sure that you don't submit invalid blocks or invalid proofs. So lower than Ethereum cross-chain latency is enabled by the base security of the AggLayer outlined above. You can read a deep dive about what makes possible. So there's a link here if you want to read more about the lower than Ethereum latency, and then you can see what it's talking about, because I'm going to share the link to this blog post. But to achieve this latency requires the development. To achieve this latency requires the development of coordination mechanisms like shared sequencer, which are basically marketplaces that enable coordination across chains and enable fast atomic transaction. So this particular lower than latency is achieved using shared sequencer, right? And the best thing is it's not a uniform requirement. There may be parts of the AggLayer that experience low latency and other parts that are not as closely coupled but can still interop safely with the AggLayer. Excuse me. So instead of having an all-to-all constantly synchronized state, the AggLayer imagine an extremely low barrier to entry where there will be chains connected pairwise with tight composability or asynchronous interaction among subset of chains, right? So all of this is still being built out. Note that the component of the AggLayer that core developers have built at Polygon Lab is not responsible for coordinating between chains, but instead ensuring the safety of chains to do so. So it's quite clear on that. So this is a Twitter post that talk more about how it's. So let's see what it's talking about. Let's look at
it. So Polygon CDK and AggLayer is really the combination that allows for the perfect user experience that devs can create. When you look at Polygon CDK, what it allows is for devs to have an out-of-the-box chain that they can customize in a way that creates the perfect user experience for whatever that user might want, whether it's a general purpose chain or a specific app chain. But ultimately, that user doesn't want to sit in that environment alone. They want to be able to take advantage of everything that exists in the ecosystem and on other CDK chains. That AggLayer ends up unifying all of these chains into one so that users get the experience that they want on Polygon CDK, but then that unified experience that they would typically expect on a blockchain, and they get that all on CDK and AggLayer.
So that sums up everything we've been talking about clearly and succinctly. So fundamentally, the AggLayer can add capacity in the form of new chains that are logically separate from one another. Yeah. So this is an extremely valuable, important property of an aggregated approach. The goal is to enable developers to build the best user experience possible for their users. So I'm going to be stopping here because basically we've discussed and this video succinctly summarized everything we've discussed, and you've got to understand what the AggLayer is all about, and then you can have this link and study more and understand it better, bridge around and see the difficulties that is in bridging and see the benefits that AggLayer presents. See you guys next time. If you have any comment about this video, please feel free to comment on the comment section, or if you have anything you want me to discuss, please also say that on the comment section. Say what's your opinion about all these things that is happening about the AggLayer. What do you think about it? What potential do you think it has? Please share on the comment section. Thank you guys. See you next time.